Now that you know how to differentiate and integrate E, we thought we'd do some more questions, and we're going to do something that's very typical on a Core 1 and Core 2 paper. We're going to ask you to find stationary points and that kind of thing. We're going to take y equals x to the 2x, which is the power of minus 6x plus 3, and we want to know what dy dx is, d2y by dx squared, and stationary points. So let's go, shall we? Right then, first thing we need to do is differentiate. So dy dx. Now remember that e, when it's differentiated, goes to 2e or whatever the constant is. So e to the 2x will go to 2e to the 2x minus 6. Now we're going to do things in a slightly different order. We're going to find the stationary point now because we want to know what the value of x is. So as we know it's a stationary point, we know that it's equal to 0. So it's 2e to the 2x equals 6. E to the 2x equals 3. Now, at this point, you're probably wondering how we're going to get effectively the value of x. Now, the way we do this is using something called ln. Now, ln is probably not something you've come across before, but do you remember when back in Core 2 logs when you had this formula, n equals a to the x equals log an? Now, with e, because it's a natural logarithm, it's always to the base e. So instead of writing this, we just write n equals e to the x, and that is equal to ln n. So what we can do is, if we want to if we want to just have the power, we can write it as ln. So we have 2x equals ln 3, x equals half ln 3. Does that make sense? Right then. We also, now we've got an x point, we can substitute it back in and see what we get with y. So y equals e to the ln 3, because it's 2 times half, equals ln 3 minus 6 lots of ln 3 plus 3. So if you put that in your calculator, now e to the ln 3 will come out as 3 because it's e to the power of ln, so it'll cancel. So that equals 3 minus 6 ln 3 plus 3 equals 6 minus 6 ln 3. That's what your y coordinate is. They will probably not ask you to find tangents, not when you've got something like that, certainly, because it's a bit horrible and a bit messy. But anyway, now we've found the x coordinate and we found the y coordinate, now all we need to do is determine what kind of stationary point it is. So we're going to do d2y by dx squared equals 4e to the 2x. Now, as we know that e to the 2x here is 3, then we can just write 4 times 3 equals 12, and therefore we know that this is a minimum point. Sorry, no, I've made that clear. This is a minimum point as the second differential is greater than 0. Well, I hope that was useful, and if you just want to have a quick look again, we've differentiated following the rules, and then when we get to just e to the 2x equals 3, we've changed it so it's 2x equals ln 3 using the rules of logs as shown here, and then we've substituted it back and found a y coordinate and differentiated it again.